This is the wiring for a Centurion D5 gate motor, South Africa's most common sliding gate operator. If you have been searching how to wire a Centurion D5 gate motor, this one screen is the whole picture. The mains, the battery, the controller, the DC motor, the safety beams, and your remote, every connection in one clean diagram. By the end of this video, you will know what plugs into what and why. You will also know the two things people get wrong most: the safety beams and how this gate keeps running right through load shedding. Let us rewind and build it up one block at a time. Here is the whole system as a chain of blocks. Follow it left to right. The mains, 220 volts from your house, feeds a charger. The charger keeps a 12-volt battery topped up. The battery feeds the D5 controller, and the controller drives the DC motor that slides your gate open and closed. That is the golden rule of 8D5, and it surprises people. The motor does not run off the mains. It runs off the battery. The 220 volts is only there to keep that battery charged. Everything else, the controller, the motor, the beams, the remote, lives on 12 volts DC. Get that chain in your head, and the rest of the wiring just hangs off it. Let us zoom into the power side, because it is the part that trips people up. Your 220-volt mains comes in and lands on the charger, a small transformer and charge circuit on the D5. That is the only place live mains should be. Wire it through a fused, isolated supply so you can switch it off safely. From the charger, two thick wires run to the battery, a sealed 12-volt battery that sits in the operator housing. Watch your polarity here: red to positive, black to negative. Get it backwards and you will damage the board. And this battery is the heart of the whole thing. It stores the energy. The motor pulls its heavy current straight from the battery, not from the wall. The charger just trickles it back up in the background. Quick note: every diagram in this video is drawn in a free editor that runs right in your browser, CircuitDiagramMaker.app. No install, no sign up. The link is below, so open in a second tab and sketch your own gate wiring as we go. Now the brain, the D5 controller card. This is where almost every wire in your gate ends up. So let us walk its connections by what they do. It takes the battery and charger in to power itself. It sends a motor output out to drive the gate. It has a safety input, a normally closed loop for your infrared beams. It has a trigger input for a push button or intercom. It has the onboard remote receiver with an antenna. And it has a couple of auxiliary outputs, a pillar light, or a gate status signal. I am not going to make up exact terminal numbers for your specific board. Always check the label printed next to each terminal on your controller. But every D5 has these same jobs, and once you know the jobs, the terminals make sense. Start with the muscle, the motor output. Two wires from the controller run to the DC gear motor that turns the pinion and drives your gate along its rack. Because it is DC, swapping those two wires reverses the direction of travel. So if your gate runs the wrong way on the first test, that is your fix. But the controller needs to know where the gate is. That is what the endstops do. Physical magnets or brackets on the rail mark fully open and fully closed, and the controller learns the travel between them, its origin. On setup, you run the gate once, end to end, and it remembers the distance. Get the end stops right, and the gate stops cleanly at both ends instead of grinding into the frame. Now, the single most important safety wiring on the whole gate, the infrared beams. You mount a transmitter on one gate post and a receiver on the other across the driveway. Together, they watch an invisible beam. If a car, a pet, or a child breaks the beam while the gate is closing, the gate must stop or reverse. That is the law of this circuit. Here is the clever part: how they are wired. The beams sit in a normally closed loop into the controller's safety input. Normally closed means the circuit is complete when all is clear, and it opens the instant the beam is broken. Why do it that way? Because it fails safe. If someone cuts the wire, if a beam unit dies, if a connection corrodes, the loop opens exactly as if something were in the way, and the gate refuses to close on anyone. A safety wire that only works when it is perfect is not a safety wire. Normally closed means a fault stops the gate instead of hiding. Next, the trigger. This is the simple push-button input that says one word to the controller: go. A wall button, a keypad, an intercom's gate release, or the button in your guardhouse all land on the same trigger terminals. Press it once, and the gate opens. Press again, and it closes, the same single command your remote sends. It is a low-voltage dry contact, so it is safe and easy to extend anywhere you need it. And the part everyone actually uses, the remote. The D5 has a receiver built onto the controller, already listening on its own frequency. You learn a remote to it once. Put the receiver in learn mode, press the button, and that handset is now paired. No extra wiring for the receiver itself. It is on the board. The one wire that matters here is the antenna. A short wire, or a proper external aerial, gives you the range to open the gate from the road instead of from your bumper. Route it up and clear the metalwork. Tuck it inside the housing and your range dies. So why go to all this trouble with a battery in the first place? One word, and it is the whole reason the D5 rules South African driveways, load shedding. Because the gate runs off the battery, and the mains only charges it, the power can go out and your gate keeps working. A healthy battery gives you dozens of cycles with no mains at all. When the grid drops, you still drive in. That battery-backed design is the D5's superpower. 2 last wiring notes. Earth the installation properly. A solid ground protects the electronics against surges and lightning, which we get plenty of, and keep the battery healthy. A tire battery is the #1 reason a D5 gets slow or stops during a long outage. Before you touch anything, 2 safety rules. First, isolate the mains, switch off, and unplug the 220-volt supply before you work on the charger side. Second, respect the gate itself. A sliding gate has real pinch points. Keep fingers, hands, and children well clear of the rack and the closing edge while you test. Power it down while you wire. Power it up only to test. So that is how to wire a Centurion D5 gate motor. End. Mains into the charger. Charger keeps the 12-volt battery full. Battery feeds the controller. Controller drives the DC motor between its end stops. The safety beams sit in a normally closed loop that fails safe. A trigger and your remote both say go. And because the battery does the work, it all keeps running through load shedding. Open the free editor, drop in the blocks, and label your own D5 wiring before you ever pick up a screwdriver. The link is below. Subscribe for a new wiring diagram explained every week, and I will see you in the next one.